All right, here's yet another example of factoring a quadratic trinomial where that leading coefficient is not a 1. So remember, check to make sure it's in standard form. So I have 12y squared at the front of my problem. The constant at the end, in this case, is a -5. So again, I'm going to go ahead and start by multiplying together that leading coefficient and my constant number at the end. So I'm going to be multiplying together positive 12 with -5, and then I'm going to list off the factors of that number. So I have 12, my leading coefficient, times the constant on the end, which is -5. 12 times -5 gives me -60. So I need to list off pairs of numbers that when multiplied together will give me -60. So my first pair could be -1 times +60. That will give me -60. Also, vice versa, I could flip those signs, say a +1 times -60. That will also give me -60. I'm just quickly going to list off the rest of these factors here. So -2 times +30, +2 times -30, -3 times +20, +3 times -20, -4 times +15, +4 times -15. Almost done. -5 times +12 and +5 times -12. Last two, we have -6 times +10 and +6 times -10. And hopefully by now you guys are starting to catch on, and our next step will be to go through that list, add those pairs of numbers together and figure out which pair is going to give us a +17, that coefficient on the middle term. So I'll just start at the top. -1 plus 60 is +59, not +17. 1 plus -60 is -59, not going to work. Then I have -2 plus 30, that will give me 28, not what I'm looking for. 2 plus -30 is -28, still not the correct number. -3 plus 20, that gives me +17. So those are the two factors that I'm looking for. So I'm going to split apart that middle term using those two factors. So my first factor was -3, so I'll say -3y. My other factor was a +20, so plus 20y. Remember, if you notice, if you were to add back together -3y and +20y, you would get back that term in the original problem, 17y there. So that's why we're allowed to split it apart like that. Then I just need to copy down this first and last term onto my problem. So I still have 12y squared out in front. At the end, I have -5y. Now I need to group my problem. Again, kind of grouping it into two halves. So my first group inside parentheses will be 12y squared minus 3y. Then in my other group, inside my other set of parentheses, I will have +20y minus 5. Now I need to go through my parentheses and divide out common terms. So looking at the first set of parentheses, well, 12 and 3, or -3, those are really both divisible by 3. Also, I see that we have at least a y term, or a y, in common in those terms, so I can divide y out. So that's what I'm going to write in front of my new set of parentheses. I have 3y, and then I set up my new parentheses there. So dividing those, starting with 12y squared divided by 3y. Well, 12 divided by 3 is 4. Y squared divided by y is y. Moving along, I have -3y divided by 3y. So -3 divided by 3 is -1. Y divided by y cancels out, so I don't even need to show that. In my other set of parentheses, well, 20 and -5, those are both divisible by 5. So that is the number I'll write in front. That's a +5 or a +5. Now setting up a new set of parentheses, I'm going to divide out that 5. So I have 20y divided by 5. Well, 20 divided by 5 is 4, and then I still have y there. Moving along, I have -5 divided by +5. That will give me -1. Remember, you're on the right track if those parts inside that set of parentheses match. So I'm going to write those as one common term. That's 4y minus 1. Now I'm going to take those other terms that I have, the 3y and the positive 5, put those together in another set of parentheses. So 3y plus 5. And again, we have finished factoring that quadratic trinomial into the quantity 4y minus 1 times the quantity 3y plus 5. Thanks for watching.